Hello friends, my name is Sudha and welcome to my channel. In this video, I will talk about data modeling of reference data in OLTP systems. So what is reference data? So we'll look at common examples. The first example is US state codes and state names and territory codes and territory names. So here we see there are two attributes, state code or territory code, state name or territory name. NJ is the state code for New Jersey, NY is the state code for New York, GU is the territory code for Guam, and PR is the territory code for Puerto Rico. Business may state a rule not to create a customer address record without a valid state or territory code. The next example is country codes and names. International Standards Organization has 3 codes for each country, and they are Alpha 2 code, Alpha 3 code, and numeric code. Alpha 2 code is the 2 alphabet code, Alpha 3 code is the 3 alphabet code, and numeric code is 3 digit code. For United States of America, Alpha 2 code is US, Alpha 3 code is USA, numeric code is 840. Similarly, for Canada, it is CA, CAN, and 124. Interestingly, for Switzerland, it is CH, CHE, and 756. So when I Googled for CH, I found that it stands for Confederatio Helvetica. So business may state a rule not to create a customer address record without a valid country code. So the next example is delivery status. So consider online store that ships products to its customers, and it needs to keep track of the delivery status of the shipments. So here is an example of the valid values. N for new label created. So that is when the label is created with the customer name and address and affixed onto the shipment. When the courier person picks it up, it is changed to P for picked up. And once it is in transit towards the destination city, it is T for in transit. Once the shipment reaches the destination city, it is onto the truck for delivery, then it is changed to O for out for delivery. And when the shipment is delivered to the customer, it is changed to D for delivered. So in this example, the two attributes are delivery status code and delivery status description. Consider a bank that offers multiple types of checking accounts to persons. So there are two attributes here, account type code and account type description. So FR, which is free checking account, there is no minimum balance and there is no maintenance fees. IC for interest checking account, which earns interest based on the balance amount. SC for student checking account, which is offered only for the students. RC for rewards checking account, which earns rewards based on the customer purchases. CC for checklist checking account. There are no checks, paper checks in this account. All transactions has to be online. Hierarchical structures could also exist. So in this particular example, we see the checking account can have 5 different types of account subtypes. Similarly, savings account can have 2 different types of account subtypes. And this picture illustrates the parent-child relationship between account types and account subtypes. Rewards level. So in this example, we'll see range of values also needs to be tracked. So for record B for bronze, the minimum points value is 1000 and the maximum points value is 4999. Okay. So in addition to code and description, there are 2 more attributes, minimum value and the maximum value. So these also form the reference data. So what is reference data now? It's a collection of code values and other attributes like description, name, and range of values. Reference data categorizes master data and transaction data. So we saw in the example, personal account type and personal account subtype categorizes account master data. And delivery status categorizes the shipment transaction data. There are other names used for reference data like lookup tables, lookup values, code tables, domain tables, reference tables, valid values tables. And this list is not all inclusive. There could be other names used by IT professionals. So what are the characteristics of reference data? Code and description or name or range of values are the most important attributes. The number of records typically vary from 2 to hundreds. The reference data does not change frequently, and hierarchical structures could also exist. Business subject matter experts decide the values for the attributes for each reference entity. Business may state the rule that master record or transaction record should have column value from the reference table. For example, an address record for a customer should be created with a valid state code. A shipment record should be created with a valid delivery status. What are the attributes of a reference entity? So typically there are 6 attributes: code, description or name, display order in the user interface. Sometimes the business decides the order in which these codes and description should be displayed in the user interface. So that's what this display order attribute is for. Active indicator, effective date when the code became valid, and expiration date when the code became invalid. In case of range, then we need minimum value and maximum value. So let's consider an online store selling products to its customers. And we have a concept of customer types. A customer could be a person or a private business or a federal government agency, state government agency, local government agency, or an education institute or non-profit organization. A customer status could be A for active, C for closed, like that. And rewards level is based on the dollar amount of the customer's purchases. We saw this earlier. So let's cover some terminologies. So business key, short form BK, one or more attributes to uniquely identify a record. Valued values are decided by the business. Surrogate key, short form SK, an attribute to uniquely identify a record. Values are generated by database or application. The values do not have any business significance. Primary key, short form PK, one or more attributes that uniquely identify a record. It could be business key or surrogate key. So in this example of customer status, we have 3 attributes: customer status identifier, which is the values are 1, 2, 3, 4, and they are generated by the database or application. Customer status code, which is decided by the business. Customer status description, which is decided by the business. So in this example, customer status identifier is the surrogate key and customer status code is the business key. So in this video, I will cover 4 different options for modeling reference data. And all the data models are developed using Irwin Data Modeler Software Standard Edition. So this is the first option. I'm calling it a normalized model. Primary key is business key. So there's a entity for customer type, reference entity for customer status, and another reference entity for rewards level. Primary key is customer type code, customer status code, and rewards level code. In the customer entity, the foreign keys are customer type code, customer status code, and rewards level code. And customer type description in customer type, that is also an alternate key, and customer status description is an alternate key for customer status, and rewards level description is an alternate key for rewards level. So no two records should have the same value for customer type description or customer status description or rewards level description. So what are the features of this data model? So we see that the foreign key is enforced by the database. Thereby it enhances the data quality of the database. And data type validation for customer type code is enforced by the database. And data length validation is also enforced by the database. So if customer type code is entered as 2 character, it will fail. So we see that data quality is enhanced in this particular data model. Now, if the business comes up with a new concept, hey, we need to add a new reference entity, then the data model needs to be changed. So another entity needs to be created. And then another reference table needs to be created in the database. Another thing, if the business wants to change the value of a specific customer type code, then it affects the customer type record, one record in the table, but it also affects the customer records, which has that value in customer type code foreign key. So this is option 1. So let's look at option 2. Option 2 is also normalized model. Primary key is surrogate key. So the difference between option 1 and option 2 is the primary key. The primary key here is customer type identifier, which is integer. It could be generated by a sequence in the database, and it has no business significance. Similarly, for customer status, it is customer status identifier, and for rewards level, it is rewards level identifier. And in the customer entity, the foreign key is customer type identifier, customer status identifier, and rewards level identifier. So in this model, if the business decides to change a certain value of customer type code, then it affects only one record in customer type, but it does not affect any records in the customer table. So now let's look at option 3, which is denormalized model. Primary key is the surrogate key. So in this option, there are only 2 entities for reference data: reference type entity and reference type value. Reference type entity is designed to store the names of all the reference types, such as customer status, customer type, rewards level. And it is also designed to store the data type and the data length of the reference type codes. And it is also designed to store whether range values are applicable for that reference type. Reference type value is designed to store all the valid values for a given reference type. So reference type value identifier is the primary key, which is also the surrogate key. The values could be generated by database sequence. Reference type identifier is a foreign key that is pointing to reference type identifier in reference type entity. Reference type code is the actual value of the codes, such as P for person, B for business. And reference type description is the description of the code values, and minimum value and maximum value attributes are designed for the range, the reference types which have range. Notice there's a self-referencing foreign key in both the entities. So for here, parent reference type identifier points to a reference type identifier. Similarly, parent reference type value identifier points to a reference type value identifier. So this way, one-to-one relationships or one-to-many relationships between the reference entities would be modeled. And in customer entity, the foreign key is customer type value identifier, customer status value identifier, and rewards level value identifier. So what are the features of this option? So when business wants to add a new reference entity, the data model does not change. Similarly, the database schema also does not change. All that is needed is new records needs to be identified for reference type table and reference type value, and they need to be loaded in both the tables. So first, reference type table needs to be loaded, and then reference type value needs to be loaded, since that's the child table. As far as data quality, the responsibility ends upon application. The data type name and the data length value are stored here. Actual validation of those values needs to be done by the application. And similarly, database and application, they need to work together. Here, application will identify the value for reference type value identifier, and that needs to be properly assigned and loaded onto customer table. And when the business wants to change a reference type code, okay, only one record needs to be updated in reference type value, and the child entity is not affected. Now let's look at option 4. Option 4 is very similar to option 3, the difference being the primary key. So here the primary key is the business key. So for the reference type, the primary key is the reference type name. Similarly, for reference type value, the primary key is reference type name and reference type code. Now, as a result, we cannot have a foreign key relationship between reference type value and the customer. The reason being, we don't want to store the reference type name attribute in the customer entity, which has the string values of customer status, customer type, and rewards level. So in this case, the foreign key enforcement is dependent entirely on the application. So these are the 4 data modeling options for modeling reference data in OLTP systems. So here the comparison of the 4 data modeling options. So when a new reference data set is added, data model changes are needed for option 1 and option 2. For option 3 and option 4, no data model changes are needed. All 4 options support one-to-one and one-to-many relationships. Option 1 and option 2 supports many-to-many relationships between reference entities, whereas option 3 and option 4 do not support many-to-many relationships. Coming to understanding the data model, option 1 and option 2 reflects the business rules. The data model clearly specifies which one is the child entity, which one is the parent entity, what are the data types, what is the data length. So all this clearly visible in the data model. For option 3 and option 4, the data model does not reflect the business rules. Data analysis is needed. So when a new reference data set is needed, database schema changes for option 1 and option 2. For option 3 and option 4, no database schema changes. And we covered this data quality earlier. So those are the 4 options for modeling reference data in OLTP systems. I hope this video was helpful to you. Bye now.